Hello everyone. Today we will solve this example by using Euler's theorem. So first of all we will recall what is Euler's theorem. Euler's theorem for two variables. If u is a homogeneous function of x and y of degree n, then x into dA by u by dA by x plus y into dA by u by dA by y is equal to n into u. That is for two variables, x ux, y uy is equal to n into u. N is the degree of the function where that function must be a homogeneous function. Okay. Similarly, the theorem we can apply for the three variables. If x, y, z are the variables, so if u is a homogeneous function in x, y, z of degree n, then x dA by u by dA by x plus y dA by u by dA by y and z dA by u by dA by z is equal to n into u. So if x1 if you take u as a function of n variables, then also we can apply this Euler's theorem as x1 dA by u by dA by x1 plus x2 dA by u by dA by x2 plus x3 dA by u by dA by x3 plus dot dot xn dA by u by dA by xn is equal to n into u. So right hand side is n into that function u. So using this Euler's theorem, now we will solve the example, that is if u is equal to x square y square z square upon x square plus y square plus z square plus cos of xy plus yz upon x square plus y square plus z square. So what we have to show is x ux, y uy, z uz is equal to 4 times x square y square z square upon x square plus y square plus z square. So here this partial derivative example we are going to solve by Euler's theorem. So as if we observe the LHS, it is nothing but the LHS of, that is left hand side of Euler's theorem. So what Euler's theorem we are going to use? X dA by u by dA by x plus y dA by u by dA by y plus z dA by u by dA by z is equal to n into u. Okay. But here u is given in terms of sum of two terms. So first term is this, second term is this. So let us take u as v plus w, where v is equal to x square y square z square upon x square plus y square plus z square and w is equal to cos of xy plus yz upon x square plus y square plus z square. So combinedly when we add v and w, we will get u. So by splitting into two terms, now we are going to solve this example. So first of all we have to check whether v is homogeneous or not, w is homogeneous or not, and after that separately we are going to apply Euler's theorem for this v and w. Okay. So let us take here, let x is equal to xt, y is equal to yt and z is equal to zt. Same substitution we are going to do here also. Okay. Then after substituting this, what we are getting is x square becomes x square t square into y square becomes capital Y square t square, z square becomes capital Z square t square. So these are all capitals divided by, again in the denominator x square is capital X square t square plus y square is capital Y square t square plus z square t square. Therefore, from the numerator we can take t square, this t square and this t square, that is t to the power 6. Together we are writing t terms, then x square, y square, z square is as it is, whole divided by, but in the denominator we can take t square as a common term. So it is left with x square plus y square plus z square. Okay. Now combining all the t terms, now this t square term we will shift to the numerator So it gives, or directly we can cancel here, that is 4. Okay. So t to the power 4, remaining term is x square y square z square upon x square plus y square plus z square. So we are getting same term which is there v in capital letters. So this can be written as t raised to n into capital V. So small v, if we can able to write as t raised to n capital V, or that is if f of xy is given, if we can able to write f of capital X capital Y, then that function is called as homogeneous. So here V is homogeneous function of degree n is equal to 4. Okay. So similarly we will check for n is equal to 4. So similarly we will check here for w also by substituting again x is equal to xt, y is equal to yt, z is equal to zt. The same method we will apply for this w. So w becomes cos of x is xt, y is yt. So here x, y, similarly y and z we will substitute yt into zt divided by x square t square plus y square t square plus z square t square cos of, from the numerator we can take t into t square common, here also t into t square. So when we take t square common, it is left with xy plus yz, and from the denominator we are taking t square common. So it becomes x square plus y square plus z square. T square will get cancelled. This is cos of xy plus yz upon x square plus y square plus z square. So w, now w we can write it as t raised to 0 because there is no t term left, t raised to 0, and rest of the term is in capital letters. So I will write it as capital W. So here W is homogeneous function of degree n is equal to 0. So once we know the it is homogeneous function, here we can apply Euler's theorem for both the terms. So for V, if we apply by Euler's theorem, x into dabba V by dabba x, because for V we are applying here y into dabba V by dabba y plus z into dabba V by dabba z is equal to n into V, but here n here for V is 4, this is 4 into V. Now we will give it as equation 1. For W also now we are using Euler's theorem, x into dabba W by dabba x plus y into dabba W by dabba y plus z into dabba W by dabba z is equal to n into W. But in this case, n is a homogeneous function with degree 0. So 0 into W is 0. So this is equation 2. Now as we know, U we will obtain by adding V and W. So here also now we are going to add equation 1 and 2. Adding 1 and 2, so term we will add it as term wise. For first term of equation 1, first term of equation 2, x is a common term. So I will take x as a common. In the first term, it is left with dabba V by dabba x plus, in the second equation first term, it is dabba W by dabba x. Similarly, in the second term, we have to take y common. So again dabba V by dabba y from the first equation second term. From the second equation, second term, dabba w by dabba y plus z dabba v by dabba z. If I am taking in the third term, if I am taking z common, it is dabba v by dabba z, dabba w by dabba z. This is left hand side. Now when we add right hand side equation 1 is 4v and equation 2 is 0. So which gives 4 into v. Okay. Now dabba v by dabba x, dabba w by dabba x, we can write it as dabba by dabba x of v plus w by the property of differentiation, y into dabba v by dabba y plus dabba w by dabba y, we can write it as dabba by dabba y of v plus w. Similarly, from the third term, z into dabba by dabba z of v plus w is equal to 4 into v. So, but we know that v plus w is u. So, x into dabba u by dabba x plus y into dabba u by dabba y plus z into dabba u by dabba z is equal to 4 times v. So, from the equation v is nothing but, so the v which we have given, which we have taken is x square y square z square upon x square plus y square plus z square. So, that we will replace here x square y square z square upon x square plus y square plus z square. This is the required answer by using the Euler's theorem. Thank you.